Hi everyone, I'm Shelley Olds from UNAVCO, and through a collaborative effort with other ESIP education members, we have created some workshops and some STEM activities that I wanted to present today. The title is Using Recreational UAVs, Drones for STEM Activities and Science Fair Projects. Without going into a lot of detail about where all this came from, because we only have 10 minutes, our goals have been to create a downloadable ebook of the STEM activities, and that's what I'll be showing today. And then virtually creating a cadre of educators who also are interested in facilitating these activities, and then creating opportunities to follow up with other members. So when we're talking about drones, what we are talking about are recreational sized drones, not the uber big ones that are more than 2 feet across. These weigh less than ½ pound, and they don't have to be registered with the FAA. And if you fly them indoors, FAA doesn't care. And they're less than $100. So in case you don't know, we have created the ebook, and the draft is available online. If you do a Google search for ESIP drone activities, it goes right to that page. And we do have the actual link down below. So I'm going to go through the different activities, and we've called the ebook, Got a Drone, Try This. And the idea is that students are receiving drones as Christmas gifts, as Hanukkah gifts, as birthday gifts. It was the most popular toy this year. You could go into just about any kind of store and find drones available. So now it's taking those toys and turning them into a science platform. Haha, they're going to learn something. So we have a couple of activities that we've put together in a draft form. And some I'll go into more detail, and others I'll just go over slightly. So we have about, I could have numbered these, I guess about 7 activities and different levels of content as well as extra material. So, the first thing that you really need to do a lot of these kind of experiments using a drone is how much can your drone carry? And it's not as easy as you would think in coming up with how you're going to create this activity and how you're going to do each run with weights is a really good starting point, especially with students who are still in school. They're learning about best practices of science and engineering, and so learning to go through the whole science process is a very good skill to learn, and this is a really good place to start. Here's an example of a flight session data, science data. Sorry, there's a typo there. Anyway, on the left-hand side is the session. So it was one session that Luann Dahlman had kindly written up her notes. And then on the right-hand side, you can see the data table. And, it has scratches, it has more notes, and you could have teachers deciding, well, okay, quick and fail and struggle could be quantified in some kind of way, or keep it in a kind of a more informal type of wording. The next one is a lot of fun. How fast can my drone fly? Again, it's a great way to incorporate science into play. And particularly if you have 2 drones, then you could say which one's faster. But, coming up with, again, kind of the data table is an important component of that. And I'm not showing the whole activity for that one. How high can my drone fly is a challenging one. As you can see in the picture kind of in the middle, you can use a smartphone to be able to calculate the angle to the drone and then come up with distance. I have an illustration on the next page. And as you can see that in this activity, it involves multiple people. So thinking of this as a science team effort, not just an individual effort, which is again a good practice as far as science goes. So here's a picture of how you might do the math side of this. You could see how a teacher might decide to have students figure this out on their own, and even to put in more math. And our experience with teaching these activities at the NSTA conferences has been, there's been a number of math and physics instructors, so they're really interested in the quantifiable components of the activities. Here's a colorful way of putting together an activity and deliberately using some colors maybe as a way to entice students into doing the activity and creating, so this one's creating a 3D view from a drone. There's software out there that's free to educators by Autodesk, 123D Capture, and it's super cool because you actually take lots of pictures that are overlapping and you walk around in a circle, or let's say you're doing an outcrop and you want a lot of overlap. It'll then stitch those pictures together, and it's not just a pretty picture, it actually is coming up with a three-dimensional model. So then you can take it from there, and the teachers I've been talking to are like, oh, this is so cool because they've got 3D printers. So they're taking some of our ideas and just blasting off into a whole new dimension of how to use this content. And then for students who might want to create a science fair project, we came up with a science fair template. And the idea is that, you know, now they've worked through how to do science experiments on their own through a kind of scaffolded process. And here they're doing it kind of solo or in small teams. And again, giving space so that students can actually write in the information. And then on the bottom right-hand corner, we have an illustration of what your poster might end up being like at the end. One more activity that now takes the idea of using the drones and the cameras that are on the drones and seeing how the images that you collect there would compare with satellite images. And here's an example of a satellite there. And then, you know, looking at when did you take the picture, calculating the area, which very important step within the science. What can you see? What's the spatial resolution? And then, you know, what's the largest feature you can see? You know, as you can imagine from space, you can see a very large feature. However, from a drone's perspective, you may not be able to fly over the top of a mountain without losing contact with the drone. And once you get that far, so now you're using the camera as a sensor, let's find other sensors. And there are small sensors that are coming out for a lot of different applications. The one on the right is one that a colleague created that has temperature and humidity as well as GPS. And so imagine putting this, attaching it to your drone, and then it opens up lots of possibilities for doing more experiments, lots of environmental activities, disaster measurement kind of activities, you know, flooding in the spring or ice cover, etc. And then taking this to one more step, one of our partners within UCAR and their Center for Science Education has developed a number of drone activities. This one that we're showing is using a drone to do a mock aerial survey of a disaster area using the camera that's on board. And I will not go through all the supplemental materials. I'm getting down to the end of my 10 minutes. So I'm just going to flip through these very quick. Within the book, we'll have Know Before You Fly, roles for science and flight teams, an illustration that shows how engineering and science, process of science can work together, a pre-flight checklist that you can use or modify, another flight data sheet, and then here's a picture of the teachers who graciously worked with us last summer and are now giving us feedback on the activities. So I want to thank you very much for your attention and hope to see you guys using this ebook. Thanks.